Hey everybody, wanted to tell you today about matrices and some of the operations that you can do with matrices. And it's really nothing but a table of numbers. You got this. Okay, nothing hard here. Um, let's see what happens. On this first screen, we've got a system of equations. I'd like to turn that into a matrix. This isn't the only thing that you can do with matrices by far, but it's probably the most common use of matrices. And it's what we've been doing anyway, and it's why we're talking about it right now. And so let me just show you how easy this is. All we're doing here is we have two equations, and you can see that we have two unknowns, two variables, x and y. And you notice that I've got my x's stacked up, my y's stacked up, equals, and all the constants over on the right-hand side like that. So this is prime for moving over into a matrix form. And all we really have to do is to take the coefficients. Okay? There's a little invisible 1 right there. There's a little invisible -1 right here. So I'll put those in. You don't really have to do that. But what we're going to do is bring those over here and put them in a little table, put them in a box. And that box is going to be called a matrix. And it represents that system of equations. What I need to do is to pick up the coefficients. And it's kind of understood that this first column right here are going to represent my x's. See how they're in the first column over here? And then the second column will be my y's, and the third column will be my constants. I'll just put a little number mark right there. It's kind of understood that there is an equal sign. Sometimes you'll see people draw a little line or a dotted line or something down there just to indicate that these are our x's and y's, and these are the equals, some number over there, whatever. But all I have to do is pick up the 1 and put it right there. And I pick up this 3 and put it right there. And I grab the 8 and to go get the 2 and I haul over this -1. The signs are important, so you need to carry those with you and make sure that everything goes in. But we have taken that system of equations, two equations with two variables, we have represented it as a matrix, and we could get that back if we wanted to, simply by saying I have 1x, and then here's a plus 3y, and then that little understood equals right there, and my 8, and see how I'm back to where I started with the equation right there. The matrix form is a shorthand. It saves you writing all those x's and y's and equals and things. You just have that table of numbers: 1, 3, 8, 2, -1, 9, and that's just a really nice, tidy way to write that system of equations. Okay? Again, lots of other things that you can do with matrices, but solving systems of equations is probably at the top of the list. Now, let me tell you about some things that we can do with matrices. These would be matrices that do represent systems of equations, and then any other thing that you want to do with matrices too. I've got some terms over here, some definitions we need to understand and be able to use. The first up would be rows. And so when I look here, I know that the rows are the horizontal lines of numbers. This one has 2 rows. This one has 3 rows. Okay. And you can see them there, 1, 2, 3. That's all we're doing. This one has 2 rows. All right. So that's all that one does right there. The number of columns obviously would be the vertical lines, the vertical stacks of numbers, 1, 2 here, and I've got 1, 2 here. You get the idea, right? This one has 4. When we talk about the dimension of a matrix, it's a combination of those, and we always do rows first and columns next. So I'm going to put here number of rows and then by number of columns. just kind of a little reminder. But here, then I could say that the dimension, the size of this matrix is a 2 by 2 matrix, whereas this one is a 3 by 2. Remember, we're doing row first. I got 3 rows and 2 columns, so I just go like that. And that's just the way we do it. All right. An element is any number in one of those boxes. So 3 right here is an element of C. The matrix name here is C. I've got a matrix A and a matrix B and a matrix C. So this is an element of matrix C, as is this and this and this and this. All of those. This one has 8 elements in it. I could refer to that one right there by writing C1, 2, which means that go to matrix C, get on the first row and the second column. I don't know that I need you to do that, but there are certainly reasons, certainly times when we want to know the address of each element in that matrix. Again, it's rows first and columns second. So matrix C, row 1, element 2, column 2, and that's kind of the address for that 3 sitting there. All right. A square matrix is any matrix that has the same number of rows and columns. Let me just, I'm going to just write R equals C here. The number of rows equals the number of columns. That's not matrix C, that's columns. Um, Maybe that's not good notation, but whatever. Square matrix. When I'm looking for a square matrix here, obviously A is the only square matrix that I have. It's 2 by 2. The numbers are the same. 3 by 2 would not be square. 2 by 4 is not square. Those are rectangular matrices. And the only square one up there is A. Um, oops. A row matrix is one. We don't have a row matrix up there, so I'll just put an example right here. It's a row. Okay, it could be anything you want: 4, 20, 85, 16. Okay, it is a row of numbers. This matrix would have a dimension of 1 row and 4 columns, so it's a 1 by 4 matrix. And because there's only 1 row, it's a row matrix. And similarly, I could have a column matrix, which, guess what, would only have 1 column. And so it could be something like this. And again, anything could be in here: 0, -4, and 16. There's a column matrix that is 3 rows by 1 column would be the dimensions on that. All right, so some basic definitions there and learning to get around with matrices. Let me show you some of the things that we can do with these. We can add matrices. If I had matrix A and matrix B, like you see up here, here's one matrix, here's another matrix. I want to add those 2 matrices. So A plus B, like that, would say, go take matrix A and add matrix B. Now, there is a little caveat here. They must have the same dimension. They have to match exactly. The number of rows has to be the same. The number of columns has to be the same in both. And if you do, then you can add these things together. And all you have to do to add 2 matrices, this is really easy, is you're going to take the first row, first column, add that in the first matrix, add that to the first row, first column in the second one. So right here, I'd have a -2 plus 8. And eventually down here, that will turn into a 6. All right. Next up, I'm going to take the first row, second column, add that to the first row, second column here. 3 plus 1. I'll have a 0 plus 5 when I do this guy plus this guy. And then lastly, I've got that 1 plus 4. And so we're just adding whatever's in each box. And again, you can see why they have to have the same dimension, right? If I had one more row over here, what would I do with it? What would I add it to? Well, you can't. So deal with it. Here's a 3 plus 1, which would give me a 4. 0 plus 5 would be a 5. 1 plus 4 is a 5. So that is the matrix sum of A and B right there. Just match them up. You can see, we'll do this one kind of quickly here. I'm going to work across that first row. Notice that my dimensions here are 3 rows and 3 columns. And over here, I have 3 rows and 3 columns. So, yep, they have the same dimension. That means that I can add these together. And very simply, I'll have 2 plus 6, which would be 8. Negative 10 and 10 would be 0. Negative 2 would be negative 4. 14 and 0. 12 and negative 12. 10 and negative 4. And 4 and negative 5. And I get that if I did it all right. Okay. So no real big deal there. We're just adding 2 matrices. Maybe you say, why would you want to add 2 matrices? Well, maybe these represent things other than systems of equations. Maybe this is the, maybe 2 gyms, 2 school gyms are combining resources and this is the number of basketballs at each. Maybe this is the number of basketballs, number of footballs, number of baseballs, and or maybe the second row represents something else. Again, you can do all sorts of things with matrices, but you can see how if I took -2 basketballs, that doesn't make a whole lot of sense, and added that to 8, when the two combine, I've got 6 of them, right? Maybe this is money. Maybe Joe owes $2 and Bill owes $8. So together when they put their resources together, they've got 6 or something. Um, all sorts of reasons that you might want to add matrices. We don't need to know a whole lot about that other than how to do it. I can multiply matrices. I'm going to show you 2 ways to multiply matrices here. The first one is called scalar multiplication. To me, I like to think about scale it up, scale it down. If I had a picture of the Mona Lisa here, there she is in all her mystical glory, the mountains behind her. I could scale that thing up and make it twice as big, right? And I just multiplied everything by 2. All right. I could scale it down by multiplying by zero point 0.3 or something, right? And making it bigger or smaller. That's essentially what we're doing here. And in this first example, they ask us to find 5C. Well, C is this matrix that you see right there. So when I do 5C, it just means take 5 and multiply it by the matrix. And it's like we're distributing 5 to each one of those things in there. So that would be equal to 5 times 8 and 5 times 1 and 5 times 5 and 5 times 4. And distribution is a nice way to think about this. I don't know that that's the same thing that we would normally call distribution, but it's like that. And we just end up with a 40 and a 5 and a 25 and a 20. Okay. We scaled matrix C up, and now every number in there is 5 times bigger than it started out. In this second example, they want us to find 3B and then subtract 2A from that. So this one's got scalar multiplication. We're scaling B up by a factor of 3, scaling A up by a factor of 2, and then we're subtracting those. And you go, wait a minute, if it's addition or subtraction, I got to make sure that the dimensions match, because otherwise I can't add or subtract them. Let's see, I got 3 rows and 2 columns, and this one's 3 rows by, okay, the dimensions match, so I can certainly add or subtract those like they're asking me to do right there. And maybe you want to write this out in a couple steps. That's kind of up to you. If you can keep up with it, good for you. But I want to do 3 times 1, 0, 0, 2, 4, -6. And then I want to subtract 2 times -1, 1, 0, 2, 0, -4. And of course, I've got to distribute all that in there. So let's do our distribution here, and then we'll do the subtraction. 3 times 1 would be 3, 3 times 0, 3 times 0, 3 times 2, 3 times 4, 3 times negative 6. And there's the scaled up version of B. And now you could do this two different ways. You could distribute, if you will, -2 to each of these and leave a plus sign out here, or you could distribute the 2 and leave the negative sign here and do a subtraction. It really doesn't matter. Um, we haven't done a vector subtraction, so let's leave this negative sign outside, and I'm going to take the 2 and multiply it by everything in there. And I'm just making a mess at this point. So 2 times -1 would be -2, 2, 0, 4, 0, -8. Okay. Now remember, I am subtracting here. Again, we could have done -2 times all that. It would have changed all these signs and added whichever way you want to go at it. But I need to do 3 minus -2. Minus negative would be a positive. So I'm adding 2, getting a 5 right there. 0 minus 2 would be a -2. When I do 0 minus 0, that's going to give me a 0. And meanwhile, 6 minus 4 would be a 2. 12 minus 0 would be 12. -18 minus a -8, that's really +8. So that would go to -10 right there. So play with a couple of those. You can make up your own and, just make up some matrices and get used to uh, doing the scalar multiplication thing, the addition subtraction thing, combinations of it like this one that we did. They're kind of fun to do. I have one more way that I want you to learn how to multiply matrices. This is not scalar multiplication. This is matrix multiplication, where instead of multiplying by a scalar, by a number that scales it up or down, it actually takes those two matrices and multiplies them together. This is a little weird, so watch this. We do have a caveat here. The number of columns in A must equal the number of rows in B. So here I have two square matrices, no problem. This one has 2 by 2, 2 rows, 2 columns. This one has 2 rows by 2 columns. And what they're saying is that this number, the number of columns in A, has got to be the same as the number of rows in B. Right here, they better be the same number. Otherwise, you can never, never, never multiply them. All right. Those two have to match. Before we do that one, let's check over here and make sure that we're good to go on that second one. This would have 2 rows, 3 columns. This one has 1, 2, 3 columns and I'm sorry, I said that wrong. This one has 3 rows, 1, 2, 3, and 2 columns. And so when I look again, I want to make sure that the number of columns in the first one is equal to the number of rows in the second one. That is true. So I can multiply these two matrices. All right. And I'll show you how to do that right now. What we're going to do when I write matrix A times matrix B, we're going to end up with a matrix here. And effectively, what we're going to do is take, when I'm going for the first element right here, first row, first column element, I need to take the first row times the first column. Now, what does that mean? Well, we're going to take this element right here times this one right there. So that's a 1 times 5. And then we're going to add to that the second element times the second element. Remember, we're working that row times this column. Okay. We'll go ahead and come down here and clean that up before we move on. But that's what we're doing when we multiply uh, matrices. 1 times 5 would be 5. 2 times 7 is 14. And that 5 plus 14 would give us a 19 right there. Okay. The first element, this would be, if this is some new matrix, let's call it M, the answer here, the multiplication matrix. This would be M11. So just like the notation for the address of that element, I've got to do the first row and the first column, and that's what we did right there. This is going to be M12 over here, first row, second column. And so for that one, I need to take the first row. Ooh, too dark. Times the second column, like that. And I'm going to do the same thing. I'm going to take, trying to keep my highlighter and my pen straight here. I'm going to take one, and I don't want yellow. I'll go with blue here. We'll take the first one times the first one. That would be 1 times 6. And then I'll take the second one times the second one. That is 2 times 8, and I'm adding those together. 1 times 6 is 6. There's a 16. I get a 22 right there. Okay. And now I've done the first row times both columns and gotten the first row, both columns. And now I have to move on and go to the second row and the first column. So we'll come in right here, and I'm going to do the second row times the first column and put it in the second row, first column. And then eventually we'll do the second row times the second column and put it over here. But let's see what that one looks like. Here I would have a 3 times 5 plus 4 times 7. Taking the first one times the first one and the second one times the second one and adding those together. And then we could go ahead and move this guy over to the second column. And do that second column. Now I'm doing the second row, second column, which is going to go into the second row, second column. We've already done this one. Maybe I should have changed colors or something. But you can see that I'm going to get 3 times 6 plus 4 times 8. All right. And we'll take one more step here. Kind of took a, oh, yeah, I don't know why I wrote that out like that. Let me just put the number right here below because I'd like to keep enough room to do this one over here. That would be 18 and 32, which would be a 50 right there. And now we don't need that so much anymore. Oh, that's what happened. I skipped down to the, yeah. All right. Well, I don't know if I can do that or not. You get the idea. This would be 15 and 28, which would be a 43 if I'm doing that right. Okay. So that's matrix multiplication right there. I should have broken it out here and then gotten the answer. Sorry about that. Um, let's try this other one. This one is kind of a mismatch, but we can multiply it again because the numbers in the middle match. Notice here this one was 2 by 2. The numbers in the middle have to match. And actually what we ended up with was a 2 by 2. So those numbers on the outside will tell us the dimension of the multiplied matrix. Okay. This one is a 2 by 3. Again, these must match in order to be able to multiply them. And you're going to end up with a 2 by 2. The number's on the outside of this thing. So let's do the same thing we did before. I'm going to take the first row, multiply that by the first column, and that will give me element 1, 1. So A times B, you could write it AB like they have up here too. That would be fine. In fact, in some cases that might be, never mind. Anyway, when I do this one, we should have left a little more room there. This is going to get big. Okay. So when I do this one, I want to take the negative 1 times the 5 and add the 2 times the negative 4 and add 3 times 2. How many ever elements there are in your matrix? You just work all the way across the first row and all the way down the first column, and you put that in 1, 1. First row, first column, first row, first column. All right? So that's the first one there. All right, I'm going to erase the shading on the first column. We're going to go to the second column now. And that's going to go into the first row, second column. First row, second column is right there. I don't know how I'm going to get all this in there, but let's see what we can do. When I do that one, I would have negative 1 times negative 1 is a positive 1. I've got a 2 times a 0, which is a 0. I've got a 3 times a 3, which is a 9. Okay? So I didn't quite get all the steps going in there, but I think you can see what happened. We'll do this next one now. We're ready to move down here to the second row, the first column. So let me highlight that one. We are now doing second row, second column. I'm going to put that in the second row, second column, which will go right there. And I just want to work all the way down that list. I'm going to have a 4 times a 5, which would be a 20. I'm going to have a 0 times negative 4, which will be 0. I'm going to have a 5 times 2, which is 10. Right there. All right. And now finally, I need to do the second row, second column. So all I have to do is move this over to right here. And when I do the second row times the second column, we're going to break that out. And we will have 4 times negative 1 is a negative 4. 0 times 0 is 0. 5 times 3 is 15. Like that. Let's clean all those up and see what we really got here. AB equals, I need a 2 by 2 matrix here. Can you see why we ended up with a 2 by 2? The numbers in the middle had to match, but you end up with what's on the outside. I've got 1, 2 times 1, 2. There's a 2 by 2 there, and that will always work for you. I'm looking at this right here. Let's get a single number. Negative 5, negative 8 would be negative 13, and 6 would be a negative 7. Moving on to this guy, 1 and 9 would be 10. 20 and 10 would be 30, and negative 4 and 15 would be 11. So there is the matrix multiplication of that. That also is good to practice. You'll have some in the My Open Math exercises, and plenty in the book too, if you want to go look at that. I'll be happy to do more of these in class. Just ask and we'll do them all night long. All right. all of this can be done in your calculator. So I wanted to tell you how to do that. You can see that the matrix functionality on this one, this is an 83 plus, same thing for an 84. If you've got some other kind of calculator that will do that, that's fine. You don't have to have a calculator that can do this. Um, it's not absolutely necessarily. You saw it's very doable by hand. Okay, but if you want to do it on your calculator, the functionality is built in there. And see how the matrix is in yellow right there? That means it's a second function. So I got to hit the second function, hit the matrix button, and there's that menu. There's actually three menus. You've got the names of all the matrices. These are memory allocations where you can store numbers in your calculator. So matrix A right now is defined to be a 3 by 4 matrix, 3 rows, 4 columns. Matrix B is not defined, but you could set it up to be any number of rows and columns you want, and so forth. If you hit the arrow key, it goes over and shows you all the math operations that you can do. You could take the determinant of that matrix, which we'll talk about. You could transpose the matrix, which we will not. It'll give you the dimension. You can fill it. You could make up a random matrix, augment. There's all kind of stuff here. The only other one that I think we might need is that RREF, which is pretty handy right there. But there's a bunch of stuff you can do with these matrices here. Row swaps, add something to a row, whatever. And then lastly, here is the matrix edit, which is where you actually put the numbers in to the calculator. So names, that's all your matrices that you can work with. B, that's all the operations you can do with them. And C, the edit menu there lets you set matrices up. I'm going to just hit A here and see how it's got 3 rows and 4 columns, and there's 1, 1, -1, and something in that column right there. It's hanging off the edge of the screen, but if you go over, there was a 0 there. Okay, doesn't have room to show you the whole thing, but if you pan back and forth, you can see it all. Okay, to get out of this, you have to quit. So it's yellow too. Second mode will quit that. I'm going to get back into the matrix thing, second matrix. Let's go down here and let's make up a matrix B, which has nothing in it right now. So I'm going to go over and edit matrix B like that. And you can see it's 1 by 1, kind of boring matrix, and there's a 0 stuck in there. That's just kind of the default. Let's say that we have matrix B is equal to um, 2, 3, 4, 0, 1, 0. And I want to put that matrix into my calculator. So you can see that I've got 2 rows and I've got 3 columns. So right here, when I tell it the dimension of my matrix, I need 2 rows. Just hit enter, put the 2, hit the enter. It jumps to the next one, and I've got 3 columns. And it goes ahead and creates that space for you right there. And now I want to put in 2, 3, 4, 0, 1, 0. You can just do that. 2, enter, 3, enter, 4, enter, 0, enter. See how it skips to the next blank automatically. So now I've got my matrix in the calculator, and I could quit. I'm done editing. All right. Second matrix, you can see that now it's filled in. I could come down here to matrix B, and it says, you want to see matrix B? And I hit enter to say yes. And there's my stuff. It's stored in the calculator now. Let's make another matrix. I'll tell you what we could do. I could come in here and say, I want to do a scalar multiplication. I'd like to multiply matrix B times 8. So second matrix, which matrix do you want to multiply? Matrix B. Okay. And what we'll do right here is we'll make a little spot to say 8B. And I think you can see what it ought to be. Let's go ahead and just for practice here, 8 times 2 would be 16, 8 times 3, 8 times 4, 8 times 0, 8 times 1, 8 times 0. That's what I should get when I hit go on this, it knows what B is, so you don't have to do anything else. It's stored in there, and there's all those numbers that we did. So you can do it by hand, you can do it on the calculator, um, but it's nice to know where all that stuff is. Let's make one more matrix here, and do some multiplication, some addition. Um, if I go second matrix, let's go down to matrix C. And I'm sorry, I want to edit that. Matrix C, enter. And right here, I'm going to create a 2 by 2, 2 rows, 2 columns. Throw some numbers in here, -3, 5, 6, and 1. Okay. Now I've got a little 2 by 2 matrix right there. And if I come in here, I'm done editing that matrix. I can get out and I could say, I'd like you to go multiply matrix B. Did I say multiply? Let's add these. Matrix B and matrix C. I think you can see already what's going to happen here. I'd like to add those two matrices, please, because your dimensions don't match. Remember how they had to be the same size? Ours are not the same size, so we cannot add those. Oh, thank you. Thank you, calculator. I forgot about that. Can I multiply them then? B times C. I can't multiply them either. Okay. So, again, the dimensions have to match to add everywhere, 2 by 3, 2 by 3, and they have to have the same number in the middle in order to um, do. So with those, I can't do either one. I kind of did that on purpose. But let's go down here and set up something else for um, matrix C. If I edit that one, and we'll just recycle. We could pick a different one, but let's go to 3 by 2 here. 2 by 3 and 3 by 2. That should work. And enter, 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 enter. These last ones don't have anything in, so we'll put something there. I'm going to go ahead and write that down just so we can have a record of it here. But matrix C, as it stands, has 3 rows, 2 columns, -3, 5, 6, 1, 4, 5, like that. Okay. So B here is a 2 by 3, and C is a 3 by 2, and the dimensions do not match, so I cannot add. But I can multiply them, right? Because the threes match in the middle. And what should I end up with? I should end up with a 2 by 2 right there. If I want to do that on my calculator, easy, easy. I second matrix and go tell it to get B. And I want to multiply that. I could have just hit enter again on it. C right there. And there's my 2 by 2 matrix that comes from multiplying those two. BC is going to give me 2833. It already did all that for me. So all that moving the row and the column and adding all the products and everything, the calculator will do all that. What if I wanted to multiply C times B? What if I wanted to multiply them backwards? Could I even do that? C is a 3 by 2. And if I'm multiplying that by this other matrix, which is a 2 by 3, notice that the middle numbers are the same. So yes, I can multiply them, but what I'm going to end up with would be a 3 by 3. So let's just try it the other way. This is one of those interesting things in math where the order depends. The order makes a difference here. If I take C and multiply that by B, then I end up with a 3 by 3 matrix like you see right there. So the order matters. Make sure that you get that going right. Of course, the other thing that we could do is to try to add these, and you can see they're not going to add no matter what. That's not even worth putting in really, but B plus C, um, it's still going to get mad at us here, right? The dimension is a mismatch. So no, can't do it. All right. So that's how you do some of that stuff on the calculator. Again, you've got a menu for all of your memory allocations, all the matrices stored in there. You got a menu called math, which were the operations, and then you have a edit where you actually put the matrices into your calculator. All right. Here's the last little slide. This is just kind of a reminder of everything that we've done. It's just kind of a summary of the rules, and um, maybe you want to screenshot that if that's handy to have on tap somewhere. Um, Real quick, the addition, subtraction, they got to be the same dimensions. You just add or subtract all the matching elements. First row, first column, first row, first column, first row, second column, first row, second, and just put them where they go. Scalar multiplication, everything inside the matrix gets multiplied by the scalar, the number outside. That's similar to distribution, no big deal there. If I want to multiply two vectors, then the number of columns must equal the number, and the first one must equal the number of rows in the second one. That's right here. The middle numbers have to match, and I'm going to end up with whatever's on the outside, like we've seen now. Okay. So that's matrices and some of the operations that we can do with it. The next section is going to be using these to solve systems of equations, and I'll show you that next time. Thanks for stopping by. Bring your questions to class and let's figure it out. Thanks.